Hi everyone, I'm Aldo, and in this screen recording, I want to present which local model is the best for Android development. So why do I want to do this? Because as you know, Android Studio now already support local models. So you can bring your own models and integrate it with Android Studio. The next question is which model I should choose. There are over 50 models in Ollama and LM Studio, and we should expect to see more models in 2026 onwards. And then next question would be like, how do I evaluate each of the models? Sure, I can do vibe coding or vibe check, but I'm looking into a more data-driven decision where I could easily compare one model into another. Bear in mind that this benchmark uh, is just a weekend project. This is not, by all means, not an academic grade benchmark. That being said, you might be thinking, really, there are no other existing benchmark in the internet? Well, actually, there are. So, Android developers slash Google announced that they will create this exact benchmark. Um, they announced it in October 2025. Yep, here. But at the time of recording, I still not see the benchmark being published anywhere. So yeah, let's just create one. And JetBrains also already have the exact benchmark. However, this is just for Kotlin only. But it's also worth your time in case you're curious about the benchmark. So what kind of benchmark I created in this presentation, right? So it's really simple. It's just 5 tasks with 16 validations, and I group the task into two tasks. The first task is to uh, basically try to emulate what Android developers do, such as creating compose, preview, unit tests, and instrumentation tests. Let me just show you what do I mean by this? So the first part is I will ask the LLM to create this compose preview for these two composables. Oh, and by the way, of course, I'm using the Now in Android repository because it's one of the most, if not the most popular Android uh, open source project that's typically used by Android developers. So moving on, the second test would be to create a unit test. In this case, I want the LLM to create a use case test for the use case layer for the get followable topics use case. And lastly, for the instrumentation test, I will ask LLM to create topic DAO test, right? That's the first task group. The second task group is to solve an actual GitHub issues. This is more like SWE bench kind of benchmark, where again it's trying to solve GitHub issues. And in this presentation, can you guess what kind of issues we are trying to solve? It is basically deprecation. That's right. I would assume Android developers handle deprecation from time to time. So yeah, why not add it as part of the benchmark? So yeah, only this basically. And for the models that will be under test will be these 5 models, which covers models with 15 billion to 30 billion parameters from 9 gigabytes to 18 gigabytes, right? So yeah, that's for the a bit about the background. Let me run through the project itself to go into a bit more detail of how the code actually works, right? There are many files, so I'll just focus on these two. How do I generate the code and how do I validate the code? So for the code generation, right? Oh, by the way, it's under notebooks, Kotlin. I'm using Jupyter Notebook with Kotlin kernel. So you can run basically a Kotlin code just like a Jupyter Notebook. And for the dependencies, I am using a LangChain4j. So this will enables me to swap one model to another easily. So yeah, after the dependencies has been set up, basically we need to connect with the LM Studio server, right? So it's reachable, and here is basically my local host with the port 1234, right? And the next part of the code is we need to define which models we are going to test, which is in this case, and the task itself. So the task itself will be defined here from the system prompt to the actual prompt. And if you notice, this is actually the actual prompt is stored in under resource and prompts. So my point here, sorry, right, okay, this one. My point here is that every model get the same prompts, get the same configuration. So in theory, they should output more or less the same code, right? But it's not. Like spoiler alert, it's not. But yeah, let me move on a little bit for the code walkthrough. The next part is to set up the resource monitor. This is so that we could evaluate the inference cost, like the peak VRAM use, and lastly the actual execution, where the LangChain4j will communicate with the LM Studio and then store the result as a CSV. So this is the examples of the code that's being generated from this. And this is a good transition to how do I validate each of these codes, right? So the main code is actually under this. It's called run validation, but I will not run through this. I know it's a big file. I haven't had a chance to refactor this, but it's basically will try execute the 16 validation that I mentioned before. For this presentation, however, I think I'm going to use this one instead, because basically what included here will be added here. But in the notebook format, it's just easier for me to explain it. So every validation for each of the tasks will have this correct syntax validation. So what does this mean? It means that the code that's generated by AI should be syntactically correct. This is important because one of the things that we want to know is whether the output is valid or not, right? Maybe a parser like 3-seater here is able to parse it, but compilers will be less forgiving, right? Any syntax error will not will make the code uncompilable. So yeah, that's one thing that I've checked, correct syntax. The other thing would be whether it depends on the task itself, but let's say in this case, I want to assert that there are only exactly 2 functions. Why? Well, I just described that you need to create exactly 2 unit test functions. So yeah, so this is another thing that I check. We can parse it and then count the number of function with test annotation. There are other validations here. I'm not going to run through each one of them. Feel free to look around on the repository later. Maybe I would jump to how I validate the diff. So this is actually the easiest part, because let me open this. Which one this is? So for diff is it's actually quite easy because we already know what's the diff, right? It's here. And if you want to get the diff format, you just need to append.diff here. Back then, I think GitHub added the diff file button, but yeah, now it's kind of hacky, but yeah, it works like this. So anyway, we already know the exact diff. what I need to do is just codify it here. I add the exact addition and deletion so that the code or diff file that's generated by each model should contains all of these diffs. So yeah, that's it for validation. Maybe a little more about this. Like all of this actually being tested against the golden reference. So if you're curious whether how do I know, right, like this code validation works, well, I know this because I've tested this against the actual diff from the code base itself, or from the enterprise enterprise model like Cloud Sonnet 4.5. So let me just jumps to the result to make it super concrete. So if I test the or run the validation against the original files and the through output generated by Sonnet, they got the answer correct. So yeah, this is no surprise here. So what I'm interested the most is like how do the local models handle this, or how correct they are to be able to pass the validations that I shared before. So this is basically the details of each of the validation that each model able to succeed, and validation that each model failed to succeed. As you see here, let us focus on GPT. All right, so for the GPT, we see that in the preview, right, it has correct syntax, and has all the required imports, correct syntax also. But for diff generation, doesn't have correct syntax. Why is that? Let us check in here. Oh yeah, so it fails because unlike, let's say, Devstral, it added these NO files, which make the code syntactically incorrect. But yeah, this is, I would say, common like in other model as well. Like this correct syntax for the task one preview and task unit test, but somehow, let me just open this. This is correct syntax, correct. But for instrumentation tests, it insists to add this backticks, like a markdown style kind of code. So yeah, it failed as this validation, which is fine, right? We are not finding the perfect local models in this case, just the best model based on the validations. So let's go to the summary, right? This is the interesting part. This is what you've been looking for. Based on this check, as you see, GPT-OSS still, not still, surprisingly, this is surprised me as well, has the highest success rate among all the models that I've tested. It has 87.5% success rate, and not just that, actually it's faster than Pi. It should be the lowest parameter models in this benchmark. And the second most model with high success rate is Devstral. It has 62.5%. But yeah, it's a bit slower than GPT-OSS, but it's still impressive. It's able to have 10 validations, and compared to the rest like 9 and 4. So to sums up, yep, only GPT and Devstral, I would say, the best local models as of December 2025, the actual models that are available during that period of time. And this is my findings about the cost of inference or creating those running this model. For a simple task for around 1700 tokens, it requires around 12 GB of VRAM and takes around 17 seconds to complete. You can check the exact details for the cost of inference here for each of the models, right? The sum, the average, including the VRAM usage. But yeah, I would say you still need around 12 GB of VRAM, which means you need like 16 GB GPU to run these models. And speaking of hardware, this just show there is a potential for consumer grade hardware, especially if you prioritize privacy, right? This local model is actually already quite reliable. Uh, it's uh, it's it's surprisingly better. However, if you prioritize the quality, I would say enterprise grade model like Sonnet 4.5 still the best options, as seen from the benchmark in here, right, in the golden result. So yeah, that's it. Um, that's that's pretty much it. I hope you find this video useful. Thank you for watching and see you on another video.